Just a brief introduction of myself before we begin. Idan Meir, I manage engineering at Argus and been here for 2 years. We have about 70 plus engineers located mostly in Tel Aviv, but also Poland and India, and develop automotive cyber products for onboard and offboard domains. Before that, I was managing a cybersecurity product development for 3.5 years at AT&T. You probably know AT&T as being one of the largest telcos in the world, but it also has a service called MSSP, which is a managed security service provider. So essentially managing security and developing cyber protection for large enterprises. So some of you are probably familiar with Argus, but just some background and highlights about us. So Argus was founded back in 2013 when our founder realized that there were no security measures at all for automotives. So we started with developing onboard solutions, in-vehicle solution, and expanded our portfolio during these years. Then we were acquired by Conti in 2015 and growing ever since. Again, Argus, 200 employees, a lot of patents, and we have invested over 600 man-years of development, and again, growing ever since. And as you can see, our customers are spread across the industry and deployed to Conti clients and to non-Conti clients. We have many projects which we work together with Conti, but also we have a lot of independent channels. So about Argus products, Argus offers two main product verticals. One, onboard software solutions, which are in-vehicle software components, and this is our basic and initial offering. And the other product vertical is our offboard solutions, which together with the onboard solution offer a comprehensive cybersecurity solution for automotive. Aside from products, from software products, we also offer managed cybersecurity services like compliance, consulting, security architecture services, and more. And today, this talk will focus on the onboard and offboard products portfolio. And just a quick and nice anecdote. So the name Argus came from the Greek mythology. So Argus Panoptis, so I hope I'm pronouncing this right in Greek, was a guardian of Hera, the queen of gods. So in the name, Panoptis means someone who can see everything. And the legend tells that he had 100 eyes all over his body and never fell asleep. So that's how we see our role in protecting the car. And the legend also tells that he was beheaded by Zeus, the king of gods, but we're skipping that part. Okay, so this was Argus. And now let's talk about the interesting stuff. So I think we're all seeing the wide explosion of software deployments in cars, and there are many reasons for that. So let's talk about electrification, which itself brings a lot of software to the car, right? EVs need some dedicated platforms and much more sophisticated software, so that introduced software to the car. And as you see, probably more than 50% of all cars sold in Europe by 2030 will be electric, and some say even more. Autonomous driving, even though this capability is still not where it was forecast to be a few years back, it's still progressing. Autonomous driving capability will grow and grow and introduce massive software deployment to the car. For example, Tesla sends and receives huge amount of data and requires strong compute resources to enable autonomous driving even today. The introduction of 5G drives that forward. It enables high bandwidth and low latency transmissions to the cars. And again, all relies on software and even connectivity. It is expected that by 2030, 95% of cars will be connected with enable OTA updates and constant network connectivity. Again, all of that is mainly relies on software. And with regard to software architecture, we see a transformation today to new architectures. It was before, to date, it is domained, and in the near future, it will be zones. And which zones are essentially virtualized software. And by that, they enable high flexibility and disabling, enabling, or updating car functions. And again, all of that is based on software, and more software will be introduced in the car in the next years. And just to provide you some perspective, and this is pretty amazing, a modern car with, let's say, about 70 to 100 ECUs would have 100 million lines of code. So 6 or 7 times greater than all these advanced aircrafts together. And again, this will only grow due to the factor that I mentioned in the previous slides. And changes happen much more faster than we think. Not sure it's clear enough in the picture, but these are horse-drawn carriages in the left image. And you can see just 13 years later how much or how fast the automotive industry has progressed. Now, with all these changes and software deployments in the car, all of that exposes what we call in the cyber industry wide attack surface. Most of these existed before, but will be more and more vulnerable with car functionality, which relies more on software. There are many points of entry where to the car platform where a bad actor can hack into the car and influence the car functionality. For example, we have the telematics channel, which maintains a connection between the car and the remote server, same as infotainment and OTA, over-the-air ECU updates. Bluetooth and Wi-Fi are also a point of entry, which require close proximity to the car, so less risky, but still a risk. We are seeing introduction of what we call V2X, which is a vehicle to everything, and it is a communication channel between a vehicle and any entity that may affect or may affected by the vehicle. And we're seeing that starting to happen, I think mainly in China, but it will definitely reach the world. So again, all of these are essentially a back or even a front doors to influence car functionality from the outside by manipulating software. And it does happen, and it does happen every day. And we can say that most of if not all brands have been hacked. We're seeing a lot of reports of car hackings, and these are being reported in public, but also non-public channels. Some of these incidents are not reported by the OEMs and fleets for kind of obvious reasons, but it does happen much more than we think and know. And with regards to financial impact, the projection is that the total cost of the industry could reach $24 billion by 2025 due to cybersecurity related recalls. It is estimated that it can cost to an OEM about $1 billion, and it also impact brand reputation, lawsuits, recalls, and overall driving reputation, or sorry, OEM reputation. And the damage is really viable, and this was demonstrated. But what was called the charity hack. So this was an incident, I think in 2015, and was done by 2 researchers, and it was presented in Black Hat, which is a big conference, cyber conference in Vegas, and they were able to hack into a Cherokee Jeep quite easily, I would say. It's not a 5 minutes work, but it took them some time, but not a large effort, and they were able to remotely drive it out of the road. So, and the real damage was a huge recall that Fiat Chrysler did, and involved 1.4 million cars, and the cost was around 1.1 billion to FCA. And this was also a case which really pushed the cybersecurity industry for automotive a few leaps forward. So up until point, we spoke about problems, and let's see what are the solutions, or in other words, what have we done about it at Argus. So we started with what we call first line of defense, which is in-vehicle onboard solutions for protection. And there we have 2 sets of protection components. One is what we call host protection, which protects the various component hosts or ECUs, or it can be other components that run in the car. And the other one is network protection, which you can think of as firewall or firewall for CAN or Ethernet. which are the main networks in a car today. So this is a software that is usually embedded within the vehicle components, usually dynamically linked with the ECU, switches, and so forth. And of course, all of our tools and the solutions are automotive with automotive grade and ASPICE compliant. So let's briefly describe host protection. So we support protection for most ECU operating systems today, like Linux, Unix, AUTOSAR, Adaptive, Classic, and our product offers few capabilities that together provide very good protection for the ECU, very good cyber protection for ECUs. So just to describe few capabilities, we can prevent unvetted actions by the OS. So we call it system limiter. Another feature is what we call platform integrity, which actually prevents any code execution that is not authorized by OEM, right? So OEM sometimes signs the artifacts, and we prevent any execution that was not authorized by the OEM. We have a nice feature called threat detection with the host protection that detects deviations or anomalies from a known security policy and allows sometimes autonomous response when any kind of event happens. So all of these capabilities together protects the ECU and make sure the ECU functionality is not compromised by any malicious actor or malicious code. And the second capability is to monitor and protect traffic in the vehicle networks. And there we protect CAN and Ethernet network, like I said, the very common networks in a car. Our solution can detect attacks with virtually zero false positives, which is very, very impressive, I should say, because it's hard to eliminate false positives. And we can also block and prevent attacks from spreading across the vehicle network. And for example, our CAN protection offers very wide feature set, like wide range of detections, like ID enforcement, DLC enforcement, the DOS, denial of service detections, some variations of brute force attacks, and many others. And for example, also our Ethernet, which is a bit more closer to IT networks, we protect against major known attacks patterns like spoofing, fuzzing, again, DOS, and our tool can provide very wide feature sets, like, for example, access control package inspection, context-based inspection, rate limiting, and some other features which you can find today in IT firewalls, for example. So now, both or even one of these set of products can offer good protection to an isolated environment or for a network, but during the years, we're seeing that it might not be enough. And really, having just in-vehicle protection is not enough to provide full, comprehensive, real-time protection. And in the last years, regulation have been introduced, like UNR 155, and adhering to these kind of regulations require additional measures besides just having onboard in-vehicle protection. And so why is it not enough, right? Why is just onboard protection is not enough to provide this full protection and cybersecurity defense? So few reasons for that. One is limited visibility for the OEM or the fleet. So really, the OEM has no or very, very limited visibility to what is happening in the vehicle. In an ECU level or even a network level. It's not like the IT world where everything is connected through an online constant network to your backend or some major component. And many ECUs and networks, like network components like gateways and bridges, most of them do not transmit these security findings to the outside. There is an understanding that the industry needs to define a common solution or protocol And the AutoSAR has came with IDSM and IDSR, which is a mechanism to send security events outside of the vehicle, but it is still very, very preliminary. Another reason is technical isolation. There is a technical isolation between components and even various CAN networks. So again, that can affect the visibility between components. Blocking is dangerous. Let's take, for example, network protection, like our product. So on some occasions, even if we detect the wrong traffic or malicious traffic in the network, we must be very, very careful in blocking it, as it might affect critical car functionality, like steering and brakes. So these are controlled, these are controlled electronically and not mechanically today. So we can't just block everything without really, really deep inspection. There are another reason is there is limited compute power in the car, and ECUs and other components. They are not able to run complex and compute-heavy detections, and even to apply machine learning and AI algorithms that can be applied on a backend or a big server infrastructure. But I think the important thing is the important reason is what we call wide fleet visibility, right? With an offboard solution that sees the entire fleet, the entire sets of vehicles, we are able to correlate between data from various vehicles, various sources, and even between components in the vehicle. And by correlate, I mean cross-check and find incidents or anomalies that are related to some incidents or some sources. And by that, identify a potential threat. And lastly, another reason why we realized that an onboard solution are not enough is the introduction of UNR regulation. And these require that an OEM should monitor, detect, and respond to vulnerabilities. And those should be mitigated with a reasonable time frame. And you can't really do that efficiently, effectively in real time with just onboard components. So we see there are a few limitations to provide protection when you have only in-vehicle solutions. And following that understanding, so Argus have added off-board, usually cloud solution, but not always, can be on-prem, but most of the products are cloud-based. So we have few off-board products, and we will talk about major two today. And we will see how together with the onboard solution, they provide a full 360 cyber solution for OEM and fleets. So the first one is Argus VVM, which is a vehicle vulnerability management. So that solution monitors and detects vulnerabilities in the ECU software in all of its phases. So it can be used during development, production, and even post-production phases. It identifies vulnerabilities relevant for the user assets. So we also provide an asset inventory for the user, and it also helps with understanding the risk of exposure per each asset, ECU, and so forth. VVM is actually used by Conti and internally and by additional clients for a few years, and we are constantly updating functionality. So let's quickly see how it looks. So this is VVM, right? The vulnerability management product. So here you can see a list of all your vulnerabilities for all your software. So you can see how many ECUs are affected by those vulnerabilities. You can also monitor the progress of the vulnerabilities, for example, if it's resolved, if it's fixed. And you can see also an inventory assets of how that software is being maintained in the overall software structure. For example, you can see that this ECU has few hardware components, and it has few software packages, and in there you have software libraries. So that provides kind of a comprehensive view of your assets. And for example, for a specific ECU, right, you can see how many vulnerabilities are there, and you can see a very good view of the security posture of those vulnerabilities and for your entire software sets. So this was VVM. as I said, a tool for detecting vulnerabilities in development and post-development cycles. And the other solution, our offboard solution, and probably I would say the more complex one is VSOC, or Vehicle Security Operations Center. Now, the main goal of VSOC is to monitor, detect, and help with resolving cybersecurity threats in fleets or in vehicles in real time or very close to real time. And in its core, the VSOC technical functionality is similar to the concept of SIEM. If you're familiar with it, SIEM is a tool for detecting cybersecurity issues in IT platforms. Before going into the technical details, let's see in just a very high level of how does the VSOC is providing that full protection. So I think we can divide it to 3 steps or 3 parts. One is what we call data acquisition. So the VSOC collects and gets data from multiple sources, and usually really any kind of source that then provide security-related data, and it doesn't need to be even software or security data. It can be driver behavior, it can be insurance data, and so forth. And we will see how many sources or the length of sources that the VSOC can provide later on. And the second part, which is the most interesting one, is what we call threat hunting, and what you see in the middle. So you have data acquisition on the left side. The data flows to the threat hunting platform, to the VSOC platform. And on the threat hunting part, we process and analyze that data by different means. And again, we'll discuss that in details later on. And the third part on the right is the response. So based upon insights and findings that the VSOC provides, we can see and assess a potential security threat and act as needed to eliminate that threat. So as I said, VSOC is targeted to use by OEMs, fleets, and to alert security threats at real time to one or many vehicles. And again, just to provide maybe a lighter diagram or a flow, these are the main 3 parts. We have data acquisition, get the data. We have threat hunting, so analyze, process, and dissect that data, and identify potential threats and handle the response. And those are the main functionalities of the VSOC. Now, it's important to mention that VSOC is not just technology solution, but really encompass 3 pillars, which is technology, people, and processes. So the technology part is to receive the data, evaluate, and surface as a possible threat. Then we have people who evaluate that threat at times, not always. Sometimes it's automatic. But if needed, they act upon it to remediate that threat. And then we have some processes to apply these steps of remediation and response. We follow what we call in the cyber terminology playbooks, which are predefined steps to handle any cybersecurity use case. And we also make sure that these playbooks also adhere to the governance and regulations compliance like UNR 155. So just a little bit of what is going under the hood of the VSOC technical solution. And again, let's flow of data. So the first step, like I said, is to get the data, like you see down below. So VSOC can receive data from multiple sources. It can be a lot of sources, and probably one of the important ones is onboard solutions. Our in-vehicle onboard solutions generate a lot of data, a lot of cybersecurity related raw data, and that flows into the VSOC. Also, the VSOC can ingest telematics data, like indications of the engine, of fuel, of any other related data that can influence cybersecurity. We also get data for fleet management system, fleet backend systems, and they also produce some meaningful data about the vehicle, OTA updates, and even mobile application logs, which for example, indicate someone has opened the door, closed the door, and we can correlate that data with additional data. So this is data acquisition. As I said, all that data is being ingested to the VSOC. And the second part, the threat hunting, that happens in the middle. And we use a few tools to do that. But before we actually analyze the data, we need to parse it. We need to anonymize the data to protect cybersecurity and store it. And all of that needs to be done very, very efficiently, as there are huge cloud costs related storage and compute related to ingesting and storing these large sets of data in that scale. For that, we use big data technologies, which were developed by the big tech companies to handle that scale, because they are probably the only ones who handle this kind of scale. For example, we use big data analytics engine called Spark, which manifested from Google Hadoop engine. To store the data efficiently, we use a format called Iceberg, which came from Netflix. And to catalog the data, we use Hive, which is Hive was originated at Facebook. So the next step is to, after we store it efficiently and ingest it, is to analyze that data and detect cybersecurity events. And this is the interesting part and the really complex part, which how we analyze and detect vulnerabilities on that data. And this is called threat hunting. And this is really the secret sauce of Argus, which is based on years of working on security products for automotives. And we're doing it in three methods, I would say. So the first one is what we call the known. We developed custom rules, which are deterministic and simply querying the data and applying rules on that data. The second part is what we call the known unknown. And there we use threat intelligence data from various sources like hacker forums and dark web and third-party companies who supply us with that kind of information. As I said, we're also using Argus vulnerability tools, which provides critical information about ECU vulnerabilities. You can see that in the previous slide. So you see on the right side, we have the threat detection engines. Sorry, on the left side, we have the threat detection engines, all of the logic that identify anomalies. And on the right side, you can see Argus VVM tool, which provide, let's call it static data about ECU's vulnerabilities and a few other meaningful insights. And we combine all of that data and capabilities to detect cybersecurity threats. And the last part is what we call unknown. And here we're applying machine learning and AI models to detect and find anomalies in the data which could indicate a cyber threat. So all of those three methods combine our let's call it really impressive threat hunting capability for automotives. And not a lot of companies in the world can really do that effectively, because they need the knowledge, the know-how, which was gained in Argus during those years, and really great technology to apply it. And with regards to the people part, so the first thing I should say is that our goal is not to involve people and process, right? We would like the threat resolution to be as automated as possible. So to some use cases, there are automatic playbooks which are being executed to resolve that use case. However, since threats are not that simple, and specifically in automotive, we need to have people involved at times. So usually there are three levels of support for that. In simple cases, we have our L1 analyst and incident manager on level 2, which first triage and alerts investigation. And at times for escalated events and incidents which are a bit more complex, we apply automotive security expert to handle that incident. So we've seen how that solution can help us with cyber incidents, but we also provide not just cyber defense, and VSOC can help with additional use case. For example, we can detect fraud incidents and eliminate car theft, and also help with protection when you need to maintain. Also help with prediction on when you need to maintain your car and other interesting fleet operational issues, which could be very important and save some money for fleets and OEMs and so forth. And just a small example of that, for fraud detection, we can see how VSOC get few sources of data, like driver behavior. For example, telematics can indicate a lot about driver behavior. So we get the telematics feed from the car to the VSOC. And some information from the fleets, like driver behavior and insurance data. And we can correlate those incidents and at times detect that something suspicious is going on, which can indicate a possible fraud. Okay, great. So this was a kind of in description of our products, and let's go for a quick demo of our solutions. So what you see here is the Argus vSIM. This is the main dashboard of the product, and this screen is the first screen that the user sees, and it shows a real-time security posture of your fleet. For example, you see what happened in the last 24 hours from security perspective. We can see how many CAN end-to-end violations were detected, the type of security events found, and other interesting information. And all of that data or display can be easily configured to add and display additional metrics like how many fleets we are protecting, our SLA levels, again, driver behavior, and so forth. We provide a very, very agile and flexible way to present that information to whoever is using the VSOC. Another interesting display is what we call alerts, the alert screen. So the alerts is, in VSOC terminology, is a possible security threat. So here you see all the alerts that we detected as incidents in the fleet or in your sets of vehicles. Now, this is just a demo platform. We can't really disclose customer information, but what we see are examples of real use cases and detection that we support. For example, you can see use cases of security detections, which are based on data from Argus Onboard solution. So data that is being generated and gathered from Argus Onboard solution and being transmitted from the vehicle to the VSOC. We have CAN, IDPS is intrusion detection and prevention system. You would see a lot of IDPS. That's the terminology for detecting cybersecurity events. So you can see many use cases of CAN IDPS. So a lot of use cases that our CAN onboard solution can detect. And also Ethernet and host IDPS. So that's our host protection solution. So all of these are use cases and examples of possible threats that our host or network solution have detected and transferred to the VSOC. And the VSOC has analyzed them and really indicated them as a possible threat. Now let's see an example. For example, let's look at this. This is what we call host IDPS, missing file signature. So our host protection indicated that there are missing signature for a specific file in the ECU. So that probably means that it was not signed by the OEM and usually indicates a malicious file that somehow someone is trying to run. So this is the alert that shows that vehicle number, where is the vehicle ID has transmitted that alert, and it's a way for the analyst to see what happened. And we also have what we call investigation dashboard. So if the analyst sees that alert and is looking for additional information, so for each use case, we have a dashboard that supplies additional information about that specific incident. And here you can see additional information about the path that were indicated as problematic, and few other additional information. Another example for an interesting use case is let's look at something which is not cyber. For example, petrol theft, right? So we see that we've indicated that vehicles were detected in geographic proximity of 1 kilometer with few level changes, while the odometer value has not changed. And we can detect that by getting location data from the car and telematics. So that might indicate a petrol theft, which was taking place at the target location. And if we have more cars, right, so we can easily identify. So here you can see that few cars, so we can see the number of VINs, have transmitted that indication for a security event. And again, if we're looking at the investigation dashboard for that specific scenario, we can see additional information for that specific scenario. And even more interesting scenario, which involves a vulnerability management product, is let's look at here at ECU software downgrade. So that is an interesting use case because in here we see that the vehicle has reported that the software version in the car does not match the telematics data that we see the software as it should be. So the OTA software we know that has, for example, 1.5 version, but the ECU itself has 1.4 version. So usually a software downgrade means that something fishy is going on, because you usually don't downgrade software on ECUs. That's a rare occasion, right? And we also can correlate that data to our VVM product, our vulnerability managed product. So for that specific ECU, our analysts can see that we have it has the latest, let's say 1.5 version, but on 1.4 version there are a lot of vulnerabilities detected, and that really indicates or might indicate that someone is using or have downgraded the ECU version to apply and use this software vulnerability, and by that to hack into the system. And we also, as I said, we have an investigation dashboard specifically to that kind of threat. And again, it helps the analyst to see a lot of additional information about this software mismatch, right? So we can see history of the version reports. You can see a map of where this has happened with multiple VINs. So usually, if that happens in an isolated area, that probably means that that something which is not good is going on. So as you can see, this is how we apply those full and comprehensive protection by applying both onboard and offboard solution. And by that, we can provide OEMs and fleets full and real-time cybersecurity protection, and also adheres to UN regulation, which mandates those kind of security measures. And here I concluded, and thank you. Bye-bye.